Hi, today we're solving problem 45. Triangle, pentagonal, and hexagonal numbers are generated by the following formulae. So here we're given the formula for triangular numbers and the first two triangle numbers, pentagonal numbers, first two pentagonal numbers, hexagonal, first two hexagonal. It can be verified that the 285th triangular number is the 165th pentagonal number, which is the 143rd hexagonal number, which is 40,755. Find the next triangle number that is also pentagonal and hexagonal. We're just going to brute force this by going over all hexagonal numbers and looking for the next one that is both triangular and pentagonal. Now when I read this problem for the first time, I thought, okay, I'll go over all triangular numbers. But that's pretty slow because there are a lot more triangular numbers than hexagonal numbers. And we can see here that the hexagonal numbers are growing much faster than the triangular and pentagonal numbers. So what we're going to do is generate all of the hexagonal numbers, and then we're going to write checks to see if a given number is triangular or pentagonal, and then we're going to check both of those. So let's go over to IntelliJ and implement it. The first thing we need to implement is checking if a number is triangular. We're going to take a number, and here we're going to be dealing with pretty large numbers because this is not too common. So we're going to have num of type long. Now, how do we check if a number is triangular? Well, we can go to the Wikipedia article for triangular numbers, and if we scroll to the bottom, we can see the reverse formula. So given the triangular number x, what is the index of that number? So the way we're going to detect a triangular number or pentagonal number is first get its index and then put that index back into the original formula to see if we get back what we started out with. So I'm going to take my number. I'm going to do val n is equal to, this is going to be math.square root of 8 times the number plus 1, and then we're going to take the square root, subtract 1, and at the end we're just going to divide by 2. And this gives us a double, since math.square root gives us a double. So I'm going to round this down to an int, because this should be an integer if it is a triangular number. Now we have to put this formula back into the original triangular number formula. So here we have the triangular number formula. And we need to watch out for longs, because here we have an integer, but the number itself is that we started out with is a long. So I'm going to start with n.2 long. So this will make all of the operations in the long range. So I'm going to multiply this by, and we don't have to do that again since n itself we know to be an integer, and we won't run into overflow with n. But here we're going to do n plus 1. And then we're going to divide that by 2. So we take this whole thing and divide it by 2. So now we can test is triangular. Let's go ahead and do it with 15. Now we can go ahead and run this. Euler 45. Okay. And we got 15. So what we did with our is triangular is we're calculating back what the number that we started out with. And to give a boolean, what we have to do is compare this to make sure it's the same thing as num, which we started out with. So now here we run, we get true. And if we give it something that's not triangular, like 14, we should get false. Okay, so our triangular check works. Now we're going to do the same thing for pentagonal numbers. So you can go to the pentagonal number definition in Wikipedia, and here we have a reverse formula.